Hello. Let's just solve the minimum path sum today. Let me read the problem. Given an n by n grid filled with non-negative numbers, find the path from top left to bottom right, which minimizes the sum of all numbers along its path. Note, you can only move either down or right at any point in time. Let's see the input in example. Grid is 131, 151, 421. Minimum path is 13111. Thereby, the output is 7. Okay, let's see my approach. First solution is backtracking. A path function with x, y, sum as parameters. Path is a recursive function. It's called for the x plus 1, y. It's also called x, y plus 1. This means that at a certain point, it can move the right side and also moves to the downside. And a current summation is added on with the next grid value of the direction. And if x equals the n minus 1 and y equals the n minus 1, update the minimum path sum with current sum value only if the current sum is smaller than the mean value updated so far. And if some value is equal or more than mean value, the recursive function doesn't need to go further by returning immediately. This is called backtracking. This means that if we draw a picture of a searching tree for down and right direction with the backtracking condition, we can cut the searching tree that doesn't need to go further because the current summation is already bigger than the minimum value. This improves the performance of the algorithm by reducing the searching space. Next approach is the dynamic programming or the memoization. The previous recursive function has been modified. Some parameter removed, and we use the memoization using the two-dimensional array, storing the minimum path value of current place from the top left position. Min is the reference of dyx, storing the minimum path value of yx position. Path function is called recursively, same as the previous backtracking approach, and current grid value is added to update the mean value, referencing the d and yx. Actually, the table D is updated from the bottom and right to the top left direction. Considering the recursive function called training, it's possible the partial mean path is independent of the previous summation. Okay, let's see the code implementing this pseudocode. Okay, let's see the code. This is the implementation of path function. As you can see, the path function is called recursively for the right side and the downside, and the memoization technique is used using TP array, which is a two-dimensional array indexed by y and x. If the current location of x, y equals n minus 1 and n minus 1, which means the reaching destination returns the cell value of the position. The performance of this code is not good, just faster than the 45.17%. So I searched another solution showing the better performance. This code used dynamic programming. The yellow colored line is the main idea of this approach. Grid ij is assigned mean value of grid I and j-1 and grid I-1 and j. Among the two values, a smaller one plus a grid I and j is assigned in the temp grid I and j. Temp grid is the two-dimensional array storing the minimum path values from the top left to the I, j. With this recurrence equation, the temp grid table is filled with the minimum path values from the top left point. This algorithm also has the time complexity O(n), but much faster using for loop instead of recursive function call. Before running the for loop, you have to initialize the left border and upper border. These border values are used as the initial values to run the recurrence equation. Okay, and thank you for watching. See you. Bye bye.